Hi again. This is module 4, machine learning. So if you remember in module 1, we talked about introduction to artificial intelligence. In module 2, overview to fuzzy logic systems. We talked about fuzzy logic operations, fuzzy sets, membership functions, and so on. In module 3, we talked about fuzzy logic control. And here in module 4, we'll be talking about machine learning. Before we talk about machine learning, let's talk about what is data science. So data science consists of three major areas: computer science, statistics, and machine learning, which we'll be learning. And the person who works in data science is called data scientist, and he's responsible for acquiring data, managing data, choosing modeling technique, writing the code. This is where the computer science comes in, and finally verifying results. And we need statistics in order to build our machine learning algorithms, which we will not be doing. And data science is all about managing the process that can transform hypotheses and data into actionable predictions. So the goal is to come up with predictive models. As we will see later, this is not necessarily the case, as we'll also be doing inferencing with machine learning, which means we want to identify the relationship or the behavior of our data. So these are some typical predictive analytic goals. Who will win an election? This is normally done in the US, for example. They use data analytics or machine learning to see how a candidate performs in the electoral process. What products will sell well together? So, for example, if you go to Lazada, um, Lazada has to figure out what are the things that people will buy together. For example, if you buy a shampoo, how can the system know that you would sometimes buy a conditioner as well? So they use machine learning for this. Which loans will default? So if you go to bank to apply a loan to buy a car or a house, they would not just give you the loan. They would see whether an applicant is suitable to be given a loan. So if an applicant can pay off the loan effectively or completely, then the bank probably will make some profit, or else they will lose money. So they have to decide earlier whether they should give you a loan or not. So they will use some algorithms to decide on that. And here are more examples. Amazon's product recommendation system, similar to the example I've given earlier. LinkedIn contact recommendation system, or in Facebook, sometimes it would suggest to add someone as a friend. So how does the algorithm know, right? So there are ways to determine that. Twitter's trending topic, and so on. And here are some applications, real world applications. So in this example, how Target is a chain supermarket in the US, figured out a teen girl was pregnant before father did. So apparently here, the Target knew that the daughter of a guy was pregnant before the father knew. So apparently the daughter was pregnant, she did not tell the family, and she was buying pregnant lady supplements online. So the algorithm knew that if a girl is pregnant now, then sooner or later there'll be a baby, and Target started sending out coupons for baby products to her home. And the father got to know about the coupons, and he was angry because he thought no one was pregnant at home. And he confronted Target, and then Target explained. And the irony here is that Target knew that his daughter was pregnant before the father knew. Another application would be in Walmart. Again, in the US, Walmart is a chain supermarket or hypermarket in the US. So normally in the US, there would be hurricanes every now and then, and people would buy food ahead of hurricane. So Walmart used their historical data and discovered that before a hurricane happens, people would buy these strawberry pop tarts more than usual. So if we could read this, the experts mined the data and found that the stores would indeed need certain products and not just the usual flashlights. We didn't know in the past that strawberry pop tarts increase in sales like 7 times their normal sales rate ahead of a hurricane. So who would know? So if you just use simple logic, you thought people would not buy strawberry pop tarts that much ahead of a hurricane. You thought people would buy water and some necessary items. So this is one of the advantages of machine learning, where you can find information which you never thought relevant or important. Another application will be predictive policing, where if you can read here, the article from Wikipedia refers to the usage of mathematical, predictive, and analytical techniques in law enforcement to identify potential criminal activity. So here they can predict before a crime happens. So apparently, if a simple robber robs a 7-Eleven, he would rob another 7-Eleven in a in the same night, because probably he or she cannot get that much money from robbing one 7-Eleven. So using this predictive policing, police would know where would be the next crime scene. So now, overview of machine learning. So it refers to a vast set of tools for understanding data. These tools can be classified as supervised and unsupervised. So supervised machine learning involves building a statistical or machine learning model for predicting or inferencing an output based on one or more inputs. So the key word here is that in supervised machine learning tools, we have inputs, we have outputs. Another set of tools is unsupervised machine learning, where there are inputs but no supervising output. Nevertheless, we can learn relationships and structure from such data. So in supervised machine learning category or set of tools, we have inputs and output. In unsupervised machine learning tools, we only have inputs. There's no such thing as output. So here, this is a wage data. So the data here, if you can imagine that you have an Excel file or a table where one column is wage, is labeled wage, the other column is age, third column is year, and fourth column is education level. So what is wage data? It contains income information for males from the Central Atlantic region of the United States. So if you just plot wage versus age, you will get this gray plot, right? It seems to be scattered all over. Nothing much you can infer from this plot. However, using machine learning algorithm, specifically if we use polynomial regression as a tool of supervised machine learning, we will get this blue line, right? So now we can say something about this data set. So left, this is wage as a function of age. On average, wage increases with age until about 60 years of age, at which point it begins to decline. So this is our inference. When I say inference, we are trying to get a relationship between the inputs and output. And similarly here, if we plot wage versus year, you would get this chain of points. The points are all vertical, no points between these two because we are dealing with year, right? So year is a discrete number. Therefore there's no points in between here. And again, if you just look at these gray plots, nothing much you can analyze. However, using linear regression, a machine learning tool, you would get this blue line. And now probably you can say something. There is a slow but steady increase of approximately $10,000 in the average wage between 2003 and 2009. So this is your inference or conclusion of the data or summary. And finally, we have these box plots, wage versus education level. You would say so the one is indicating the lowest level, no high school diploma, and 5 is the highest level. This is from the data set. So when you plot a box plot, you will get this various boxes, and the thick line is what we call the medium. This edge is the first quartile, and this edge is the third quartile. Okay, you can check on your statistics what those mean. So now your conclusion, you can see that thick line really increases, your median increases, right? What that means is that on average, wage increases with the level of education, which kind of makes sense, right? As you get more educated, probably your salary increases as well. So in this setting, for example, here you can see that this is how our model, the blue line, would look like, right? In a block diagram. The input to our model is age, the output is wage, and what we have in this box is a set of mathematical equations representing the polynomial regression. Next, this is the gene expression data. You can imagine that the data set will look something like this, Z1, Z2, and this is the cancer type. Okay, so this data, this is called the NCI 60 gene expression data. Each point corresponds to one of the 64 cell lines, so you should have like 64 plots here. When we use an unsupervised machine learning tool called the clustering algorithm, we would obtain, so what the algorithm does is that it would break your data into groups. So the algorithm gives us 4 groups, and we have colored these groups using blue, green, light blue, and red. Next, when we cross-check with our label here, right, we have this plot. So this plot is similar to this, but now what we did is that we have changed the plot according to the cancer type. So one cancer type is green triangle, the other cancer type is blue circle, red circle, and so on. If you look at these two, well, let's just read this. Right, we are referring to this. Same as left panel, except that we have represented each of the 14 different types of cancer. So you should have 14 different shapes and colors here representing the cancer types using a different colored symbol. Cell lines corresponding to the same cancer type tend to be nearby in the two-dimensional space. So if you compare these two, this is what given by your clustering algorithm, an unsupervised machine learning tool. This is just our data. Okay, so when you check, it seems that some cancer types, they happen to be close to each other. For example, let's look at this, right? This green triangle cancer type, whatever it is, we don't know. They happen to be close in the same group. And this circle magenta cancer type, again, they are in one group. And this one as well, the blue circle cancer type, and they are in one group. So they are closer in the gene expression data. So from this, you can get a new information. Now, what is machine learning? We have to look at another example. Suppose we are consultants hired by a client to provide advice on how to improve sales of a particular product. The advertising data set consists of the sales of that product in 200 different markets, along with the advertising budget for the product in each of those markets for three different media: TV, radio, and newspaper. So you have to imagine how your data set would look like. So you would have a column called sales, a column called TV, radio, and newspaper. Right? Sales is that sales of that product for 200 different markets. So you can imagine there are 200 rows of your data. And TV, the column TV is the budget for um, advertising in that media, and radio is how much they spent for advertising in that media. So let's look at the data set. So this is our data set. So first of all, we have 4 columns: TV, radio, newspaper, and we have 200 rows. Okay, 200 rows. So this is our data set. This is the sales, how much they got, the sales of that product. This is how much they spent in TV advertising in market number 1. So the plot displays set sales in thousands of units as a function of TV, radio, and newspaper, which means sales versus TV, sales versus radio, and so on. Okay, so what from this plot can we say that advertising in these medias, does it contribute to sales? So perhaps by just looking at the data set without doing any machine learning algorithm, perhaps this is the obvious one, because there's a trend. So you can see that as we increase the advertising in TV media, sales seems to be increased. So it's not possible for our client to directly increase sales of the product. On the other hand, they can control the advertising expenditure in each of these 3 media. Right? Obviously, they cannot increase the sales directly. They can only indirectly control the sales by advertising in TV, radio, and newspaper. Therefore, if we determine there is an association between advertising and sales, then we can instruct our client to adjust advertising budgets, thereby indirectly increasing sales. So this is an example of an application of machine learning. You have your data set, you have to advise your client based on application of machine learning on the data that is given. So you have to find information from your data set using machine learning. In other words, our goal is to develop an accurate model, machine learning model, that can be used to predict sales on the basis of the 3 media budgets. So next we have to decide what are our input variables or predictors, and what are our output variables or responses. Okay, so in this setting, the advertising budgets, TV, radio, and newspaper, those are our input variables, and sales is our output variable. Looking at our data set, all this is our output. 1 or 2 or all 3 of these are our inputs to our machine learning model. So generally, suppose we observe a quantitative response Y, in our case is sales, and P different predictors or inputs. In our case, we have 3 of this, so P equals to 3. So we always assume that there is some relationship between Y and X, and the relationship could look like this. So y equals to fx plus epsilon. Y is our output, sales. X is a vector of inputs, TV, newspaper, and radio. F is some fixed but unknown function of x1 up to xp. So it can be a mathematical equation, can be rules, can be statement, anything. As long as we can obtain output given those inputs, then F is our machine learning model. Epsilon here is a random error term which is independent of x and has mean 0. We always assume that there are errors in our data set. We will see how the errors look like. In this formulation, F represents the systematic information that X provides about Y. So we assume that there's always a systematic relationship between X and Y in the form of F. So for example, if let's say we have another data set called income. Okay, so if we plot income versus years of education, this is how it might look like. The red dots are the observed values of income in tens of thousands of dollars and years of education for 30 individuals. So here you can imagine your data set would look like you have two columns, income and years of education, and you have 30 rows. When you plot, this is what you get. The blue curve represents the true underlying relationship between income and years of education, which is generally unknown. Okay, so the blue one is the actual relationship, right? This is what we want to find using machine learning tools or algorithms. So often we will get either very close to this blue line or not, right? That depends what model you used and how accurate is your model. Right? So we always assume in our machine learning experience or analysis that there is a relationship between our columns, right? Our input and output. So in this case, let's say this is the actual relationship, right? Governed by the law of nature or whatever. So if we look back, we have epsilon, right? So the blue line is the F, epsilon is this one, and there's always an error between our data and the true relationship. The black lines represent the error associated with each observation. Note that some errors are positive and some are negative. Overall, these errors have approximately mean 0. So what is machine learning? In essence, machine learning refers to a set of approaches for estimating F. So we want to find this blue line. We want to find the true underlying relationship as close, as accurate as possible. So here, if you have two inputs and output, two inputs years of education, seniority, and one output income, our goal in machine learning is to find this surface. It's not a line anymore because we have three-dimensional data. We want to find this blue surface. So this is a rough summary of types of machine learning techniques. We can say most machine learning problems fall into one of two categories, right? They are supervised machine learning problems where we have inputs and output. We want to find a model that relates the response to the predictors, which means a model that relates inputs and output. The goal here is to predict the response for future observations, and this is called prediction, or to better understand the relationship between the inputs and output, or this is what we call the inference. And some methods in supervised machine learning is linear regression and logistic regression. How about unsupervised machine learning? Here, for every observation, we have a vector x but no associated response y. We have no response variable to predict. This is referred to as unsupervised because we lack a response variable that can supervise our analysis. The aim is to understand the relationships between the variables or between the observations. We just want to find the relationships or extract any useful information, as we saw in the cancer NCI 60 example a minute ago. And one of the methods will be cluster analysis or clustering. The goal is to ascertain whether the observations fall into relatively distinct groups. And from these groups, you can get new information or useful information. So once again, machine learning problems or tools can be categorized into supervised and unsupervised. In unsupervised machine learning, the objective is for inference. Inference means to get relationship or to extract useful information about your data set. In unsupervised machine learning, there are two objectives. The objective is one of these two, either prediction or inference, or sometimes both. All right, predictions means you want to generate output based on future or new values of inputs. Inference, once again, is to get relationship or to understand how your data behaves. This is a block diagram depiction of the supervised machine learning. You have inputs and you have output. If the output is numeric or a number, we call that regression problem. If the output is a class or category, for example, yes, no, old, young, or any label, then the problem is called classification. Okay. So here are some exercises where you can try in your own time. In this first exercise, you have to explain whether each scenario is a classification or regression problem. Indicate whether we are most interested in inference or prediction. So, for example, if we talk about this, we collect a set of data on the top 500 firms. For each firm, we record profit, number of employees, industry, and the CEO salary. We are interested in understanding which factors affect CEO salary. So obviously, this is a prediction problem because this is output. Sorry, obviously this is this is the output. I'm not saying okay, this is not a prediction. This is we have output CEO salary and we have inputs profit, number of employees and industry. All right. And this word we are interested in understanding which factors. That shows this is not a prediction problem, but this is an inference problem. Okay. Remember, prediction means we want to generate exactly the output given new or future values of inputs. But here we don't want to generate any new outputs, but we want to know which factors affect the salary. So this is an inference problem. And because salary is numerical, this is a regression problem. This is not a classification problem. Okay. And for the rest of these examples or exercises, you can try your own and discuss among yourself. The next exercise, you will now think some real life applications for machine learning. Okay, again, you can do this in your own time and we can discuss next time.